after Betelgeuse explodes, Earth's night sky could become as bright as daytime, meaning we might not need artificial lighting for at least half a year. To understand just how spectacular this explosion would be, we first need to grasp the true scale of Betelgeuse itself. Its size is so enormous that it's almost terrifying. If Betelgeuse were placed at the center of our solar system, replacing the Sun, its surface would engulf Mercury, Venus, Earth, and Mars, and might even extend close to Jupiter's orbit. Compared to it, the Sun would look like a sesame seed placed next to a massive hot air balloon. Yet this immense size is actually a kind of bloated fragility, a sign of a dying star. Deep inside Betelgeuse, a final tug-of-war is taking place between gravity and nuclear fusion. The star's enormous mass generates an overwhelming inward gravitational force, constantly trying to crush it. At the same time, fusion reactions in its core release vast amounts of energy, creating outward pressure that resists collapse. For the past 10 million years, these two forces have been in perfect balance. But now, the core fuel of Betelgeuse is running out, and gravity is destined to become the ultimate winner in this cosmic struggle. Inside, Betelgeuse is structured like an onion with countless layers. As hydrogen becomes depleted, the core is forced to burn heavier and heavier elements to maintain the temperature needed to resist gravity. This process becomes increasingly frantic and short-lived, like a wild celebration, spiraling out of control. Hydrogen burning can last for millions of years, but by the final stage, silicon fusion, it may take only days or even hours to burn through completely. Eventually, the fusion chain reaches a dead end. When iron forms, fusion no longer releases energy. Instead, it consumes it. At the very moment, Betelgeuse's core becomes filled with iron. The outward radiation pressure that is held for tens of millions of years suddenly vanishes, and in that instant, the ever-waiting force of gravity achieves an overwhelming and decisive victory. In less than a second, the outer layers of Betelgeuse collapse inward in a violent freefall at nearly 25% the speed of light. Matter equivalent to millions of Earth's crashes together in an instant. The core is compressed to an extreme state, and its temperature soars to hundreds of billions of degrees. This unimaginably powerful inward triggers a violent rebound. A shockwave bursts outward, carrying immense energy and tearing apart the star's outer layers in a split second, giving birth to a dazzling Type II supernova. In that single, the energy released is comparable to the total energy our Sun will emit over its entire 10 billion year lifetime. Astronomers estimate that at its absolute peak, Betelgeuse's apparent magnitude could reach around 10 to 12. For comparison, a perfect full moon has a brightness of about 12.7. This means the explosion could approach, or briefly rival, the total brightness of a half moon or even a full moon. However, despite its immense brightness, it would never appear as a large disk like the moon. The distance is simply too vast. No matter how bright Betelgeuse becomes, to the naked eye, it will always remain a point of light. This leads to a fascinating visual effect. When you walk under a full moon, the light feels soft, and shadows are slightly blurred. But if Betelgeuse were shining as a supernova, it would resemble an ultra-powerful high-pressure sodium lamp hanging in space. Saying you wouldn't need lights at night is a bit of an exaggeration, but partly true. You could clearly see the ground and walk safely, and might even barely make out large text on a page. Yet because it is a single-point light source, shadows would appear extremely dark. Entire cities would be cast in a strange, cold, almost sci-fi-like illumination. The most breathtaking aspect of this cosmic spectacle is that for about 2 to 3 months, you would be able to clearly see this brilliant star, even in the bright blue daytime sky. After that, as radioactive elements decay and the expanding gas cloud cools, its brightness would begin to fade very slowly. The entire visible phase could last for as long as 6 months to a full year. When it finally fades from view, the familiar constellation Orion will forever lose its left shoulder, becoming an incomplete figure. When people hear supernova, their first reaction is often fear. Could such a violent cosmic explosion, releasing gamma-ray bursts and high-energy cosmic radiation, strip away Earth's ozone layer and scorch all life? The answer is, we are completely safe. You can simply enjoy this cosmic firework. The lethal range of a supernova's destructive effects is typically within about 50 light-years. Inside this death zone, intense streams of high-energy particles could indeed destroy a planet's atmospheric shield and trigger mass extinction. But fortunately, Betelgeuse is about 600 light-years away. At that distance, the inverse square law becomes our greatest protection. The explosion's radiation is vastly diluted as it spreads through space. By the time it reaches Earth, our atmosphere can easily absorb and deflect most of these high-energy rays. So when will Betelgeuse actually explode? Astronomers say it could be tomorrow, or 100,000 years from now. On astronomical timescales, those two possibilities are almost the same. At the end of 2019, Betelgeuse experienced a strange dimming event that sparked global excitement. Many thought it was about to explode, but scientists later confirmed it was essentially the star sneezing, ejecting a massive cloud of dust that temporarily obscured its own light. The most fascinating part, however, is the limitation imposed by the speed of light. since Betelgeuse is 600 light-years away. What we see every night is actually how it looked 600 years ago. If tonight our sky were suddenly lit by a supernova brighter than the full moon, it wouldn't mean Betelgeuse just exploded. It would mean it already collapsed around the year 1426. That blinding flash of destruction and rebirth would have been racing through the silent vacuum of space for 600 years, passing through vast, desolate interstellar dust, crossing the rise and fall of civilizations, only to arrive tonight, striking your eyes as you gaze up at the sky. In a sense, Betelgeuse's supernova is like a telegram from the universe, one that is destined to arrive. Whether it lights up our sky tonight or shines for future generations, it reminds us of a deeply romantic scientific truth. The iron in our bodies, the zinc flowing in our blood, even the gold and a wedding ring, all were forged in the extreme conditions of supernova explosions billions of years ago, from stars like Betelgeuse. So if one day the night sky is truly illuminated by this brilliant jewel, there is no need for fear and no reason for surprise. We only need to step outside with a sense of awe and, under the sharp shadows it casts, witness the magnificent final curtain call of an ancient cosmic creator.